A single acting steel hammer weighing 2400 kg and falling from a height of 1 meter drives the pile to an average penetration of 0.75 centimeter and the last few blows under the last few blows. So determine the allowable load of the pile. By using engineer's news formula, you know that eta is equal to WH by 6 into S plus C. So where single acting hammer C value is going to be 0.25 and the average penetration under the last few blows is 0.75. S is 0.75 and W is given as 2400 kgs and the height of fall H is 1 meter, that is 100 centimeters. So by substituting these values in the equation 1, zeta is equal to W is you will get eta is equal to 40,000 kgs, that is equal to 40 tons. So option A is correct. The pressure that builds up in pore water due to load increment on the soil. So if the soil is contains the water particles, so the pressure is going to build up because of the external load on the soil. So this pressure we can call it as excess pore water pressure as or excess hydrostatic pressure or excess or hydrodynamic pressure. So all of these were correct. Calculate the area of an irrigation channel in alluvial soil according to the Lacey's silt theory. So the full discharge is given as 10 cubic and the Lacey's silt factor is 0.9 and the slope of the channel were given. So we know the relationship for the Lacey's silt factor. V is equal to QF square by 140 whole power 1 by 6. That is equal to Q we know 10 cubic and 0.9 silt factor and 140 whole power 1 by 6 is 0.62 meters per second. We have to calculate the area of an irrigation channel. A is equal to Q by V. 10 by 0.62, that is 16.13 meter square. So option D is correct. Base period for a particular crop is 50 days and the duty of the canal is 500 hectares per cubic and the depth of water will be. We have to calculate the depth of water. So we know the relationship between the base period and the duty in the depth of water. Delta is equal to 8.64 base period by depth duty. So 8.64 base period is in days and duty is in hectare per cubic. So we will get it in terms of meters. So 8.64 empirical relationship. So we have to be very careful about the dimensions. Units 500 gives rise to 0.864 meters, that is 86.4 centimeters. 86.4 centimeters, option C is correct. Is irrigation water having the concentration of different ions is given as 23 and 1 milliequivalent per liter respectively. Then the water will be classified based on the sodium adsorption ratio. Sodium adsorption ratio SAR, we can write it as Na plus divided by root of Ca plus Mg plus divided by 2. So the concentration 20 by 4 by 2 under root 20 by root 2, that is 14.14. So we know that less than 10% of sodium adsorption ratio gives the low, sodium 10 to 18 gives the medium, 18 to 26 gives the high, so greater than 20 very high. 14.14 will come into medium. So option B is correct. Question is, a trapezoidal channel has a bottom width. We will represent it in the figure. Bottom width of 6 meters and the side slope of 1:1. The depth of flow is given as 1.5 meters. So it is going to be 1.5 and it is 1.5. This is 6. Total top width is 6 plus 3, that is 9 meters. Discharge is given as 15 cubic meters per second. So we know that discharge is equal to AV. Calculate the velocity. We have to calculate the velocity Q by A. So if we are able to calculate the area of this rectangular section, then we can calculate the velocity of flow. Area of cross section A is equal to half 6 plus 9 plus half into 2 into 1.5 into 1.5, that is equal to area we will get it as 11.25 square meter. By substituting the value in the equation 1, Q is 15 by 11.25, that is 4 by 3 meters per second, or we can write it as 1.33 meters per second. So 4 by 3 meters per second, option A is correct. Here we have to calculate the specific energy for the above with the above data. Specific energy E is equal to H plus V square by 2Z, where H is 1 point, depth of water is 1.5 meters plus V square is 1.33 square by 2 into 9.81, that is 1.591 meters. 1.591 meters, option B is correct. Question is, a 40 mm dia jet of water strikes normally against a plate held in position and occurs a force of 900 newtons on the plate. Determine the jet velocity. This is a simple question. The jet velocity we can calculate by force is equal to pi by 4 d square area into density of the water 998 into v square, where we can calculate v is equal to 26.76 meters per second. 26.76 meters per second, option B is correct. We have to calculate the discharge. So the discharge is equal to A into V. A is pi by 4 d square into V. It is, by substituting the value of V from the above question, you will get the value is 0.0337 meter cube per second. 0.0337 meter cube per second, option A is correct. Option is a reinforced rectangular beam of rectangular cross section was designed to resist a bending moment of 150 kN meter. Compute the tensile stress in steel is 114 MPa and the compressive stress in extreme fiber of concrete is 5 MPa is given, and the modular ratio is given as 18. So we have to find out the depth of rectangular beam by assuming B is equal to 0.6 d. So as per working stress method, we know that ND is equal to D by 1 plus sigma ST divided by M sigma CBC. So where N is the coefficient of balanced depth and D is the effective depth. Sigma CBC is permissible compressive stress in bending in concrete. So ND is equal to D. We know that modular ratio is 280 divided by 3 sigma CB. We have to calculate M sigma CB, that is equal to 280 by 3. So D divided by 1 plus 140 sigma ST is given as 1 sigma 140, and MCB is 280 by 3 from this. So ND is equal to, by calculating this, we can get 0.4 D. Moment of resistance with respect to compression is given by M is equal to 0.5 B ND sigma CB D minus ND by 3. So by substituting the values, the value of bending moment is given as 150 into 10 to the power of 6. All the dimensions has to be in a single unit. So ND is 0.6 D, 0.4 D, ND we find out into sigma CB into D is D minus 0.4 D by 3. All the terms has to, we are converting into. From this, sigma CB is 5.18. You can substitute these values in this one. So by solving this equation, you will get 653 mm as effective depth. So